You know, if you work with logarithms long enough, you're going to get pretty frustrated, and they're not as hard to estimate in your head as people usually think. But this Taylor series, it's not a Maclaurin series, it's a Taylor series for logarithm, is going to show you why part of the frustration is that log just takes forever, and we're in a world where forever really starts to mean something. So let me remind you what's going on with Maclaurin series. What you have is some function, and the coefficients. Oops. But what you're doing is you're centering everything at A instead of at 0 like you would with a Maclaurin series. So this is a Taylor series. And the problem is when, let's say what the coefficients are. The coefficients are f nth derivative at A over n factorial. So this is something, if I had a sit-down exam and needed a 3x5 card, this is probably something I would put on it. Now, so that means we're going to start taking a lot of derivatives. Some functions you can't take a lot of derivatives, it gets too complicated. Other functions like polynomials, you take a few derivatives and everything else is 0, and what you're going to end up with is a polynomial. Big woo. But here, when we start with f of x is natural log of x, f prime of x is 1 over x, one of the most amazing facts. That's why the natural log is natural. Second derivative is minus 1 over x squared. Third derivative is 2 over x cubed. Fourth derivative, usually it takes 4 to see what the pattern is 2 times 3, minus 2 times 3 over x to the fourth. And so there's a few of the derivatives. Those are things that you did in Calculus 1. You may not have gone this far. I mean, you probably took each of these derivatives but didn't see how they were all connected to logarithm. So here we're going. Now you see here you got this factorial thing going on top. The next one's going to have 2 times 3 times 4, and that will be not 5 factorial, but 4 factorial. So that's what's going to be going on. Now you see right away that we can't do this at 0 because it would be dividing by 0, and as everybody knows, that's how I got this scar in 8th grade. So what we're going to do is displace our interest and do this near 1. So f of 1, natural log of 1, that's 0. F prime of 1 is 1 over 1. I'm going to simplify that. I probably shouldn't, but that's 1. F double prime of 1 is minus 1 over 1. F triple prime of 1 is minus 1 times 2 over 1. I'm sorry, plus 1 times 2. Fourth derivative is minus 1 times 2 times 3 over 1. So the bottom here is always going to be 1. And what we're getting here, fourth derivative, 3 factorial. So the general form here is going to be the nth derivative is, it's going to have 1 on the bottom and n minus 1 factorial on top. And then the signs are going to alternate. So you get plus, minus, plus, minus. And the way you get that alternating sign is by taking minus 1 to a power. Now, it's not to the nth power. Here, n would be 2, minus 1 squared is 1. So what it is the n minus first or the n plus first power. Your choice, it won't make any difference. So there we go. That's the nth derivative. And to get at the nth coefficient, we just divide this by n factorial. And so that's where things are going to get a little bit bizarre. So the nth coefficient, I was using c's before, so I will do that again, is I'm going to copy down the nth derivative, minus 1 to the n plus 1, over n minus 1 factorial on top, divided by 1. And then I'm going to divide that, you're going to divide it too, by 1 over n factorial. Now, think about this for a second. N minus 1 factorial, that means 1 times 2 times 3 up through n minus 1. N factorial means 1 times 2 times 3 up to n minus 1, and then times n, and everything cancels except the n here. So what we're left with is that this coefficient is minus 1 to the n plus 1 over n. Boom. And so that tells us that the natural log of x is 0. Don't be so pedantic. Yeah, it's okay. Plus x minus 1 over, where are we at here? N is 2, so sorry, x squared minus x squared over 2 plus x cubed over 3 minus x to the 4th over 4, and so forth and so on. I'm sorry I messed that up, but if you look that up in the book, you'll see that you could write it out more simply. This thing converges really slowly, and that's part of the frustration with logarithms. It takes forever to figure out what a logarithm is, and that's why the harmonic series diverges. This is, when x is 1, this is alternating harmonic, and so it converges just barely. So natural log, you just get this x to the n over n thing with the signs alternating, and very natural, goes on forever. And one thing that you do, so if you write this out and go to like 4 million terms, you will stay safe. I don't recommend it, but